Okay, we are welcome. Welcome to Chapter 3 Test Study Guide. We're just going to get started on number 1. So number 1 says graph the exponential function. Right in the statement, it tells us it's the exponential function, so we know which parent function to use. The parent function here, we're looking at what's the base, and the base here is 2. So that means my parent function is 2 to the x power. So let's start with that table. So my table is always the same. It's an exponential. So my x values are -1, 0, 1. My y values are going to be 1/2 because 2 to the -1 makes it 1/2, 1 and 2 because 2 to the 0 is 1, 2 to the first is 2. And then we're just going to apply our transformations. So we look at our first transformation is that negative on the outside. It's on the outside of the function. When it's within the exponent, that's like within the function. And when it's not in the exponent, that's outside. So when it's outside like this one, it is a change to y. And then the 3 is within the exponent. And so when it's the 3, or when it's within, it's going to be a change to x. So this is going to be a change to x. So that means to our parent function tables, when it's a change to x, we do the opposite operation. So instead of adding 3 to all of my x values, we are going to subtract 3 from all of my x values. So from -1, 0, 1, so my original x values, I'm going to subtract 3 from everything. Now to my y values, what I'm going to do, this is saying -1 times. So to all of my y values, I am going to multiply them all by -1, or just the opposite sign. So that would be 0.5, just 1/2 is a decimal, 1 and 2 all being multiplied by -1. And so that gets us our final parent function, or not our final parent function, our final transform table. So that's going to be the table for -2 raised to the x plus 3 power. And so my x values are -4, -3, -2, and my y values are -0.5, -1, and -2. So before I do anything, I'm going to figure out where my asymptote is, and I'm going to graph that. So my asymptote for my parent function of any exponential is y equals 0. So then I think, okay, how did my y values change? And they were multiplied by -1. But -1 times 0 just gets me the same asymptote at y equals 0. So that is a horizontal asymptote going through right here along the x-axis there. And then I can just plot my points. So -4 is at -0.5. -3 is at -1, and -2 is at -2. And then I know it's going to be a curve. So I'm going to draw that in. And there's my graph. So then I can just answer my following questions. So my domain of an exponential is always going to be -infinity to +infinity. Now the range is always just, I look at the graph for the range. The range is bottom to top. So it's going down forever. So it's -infinity, and then it goes to 0. It never hits 0. So we use a parentheses. And then we can talk about the transformations. The negative caused the reflection. And remember, a negative always causes a reflection. And so it reflected over the x-axis. So the negative caused the graph to reflect over the x-axis. Remember, when you talk about a reflection, you need to say what it reflected over. So you can't just say it caused a reflection. You've got to say over what specifically. And then the +3 was a change to x, but notice it shifted to the left. I had to think about my rights and lefts. So the +3 moved the graph left 3 units. And that's 1. So that was our first exponential function. We have another example of an exponential function in 2. So let's get to that one. Again, I know it's an exponential function. It says graph the exponential function. My exponent, there is no log, even though you see an e. I know you guys think that that's going to be a log. It's not. It's just an exponential function with a base equal to e. So my parent function here is f of x equals e to the x power. So I'm going to start with that parent function table. My x values are always the same, -1, 0, 1. And then my y values are going to be 1 over e, 1, and e. So now I'm just going to apply my transformations. So I look to see what everything is. And so I look and the 3. So the 3 is on the outside. It's not part of the exponent. It's outside of it. And so that's going to be a change to y. And then same with the -1. The -1 is outside of the exponent. It's not built into the exponent like that +3 was up above. And so because this is, again, outside, this is also a change to y. So we have 2 changes to y in this one. The x values are not changing at all. So they are staying -1, 0, 1. So what this is saying 3 times. So all of my y values, we're going to multiply by 3. And then with a change to y, we do the same operation. So this is -1. I'm going to subtract 1 from all of my y values. So that means, and for 1 over e, I'm just going to get that as a decimal. I'm going to use my calculator. 1 divided by e gets me 0.37. So to all of my original y values, I'm going to first multiply by 3. We follow our normal order of operations. We multiply before we add or subtract. And then I'm going to subtract 1 from all of those values. And now I can get my final table. My x values stay as is. I'm going to use my calculator here. I'm going to multiply by 3, subtract 1, and I get 0.10. And then 3 minus 1 is 2. And then 3 times e minus 1 gets me 7.15. Now, again, before I graph this, the first thing I'm going to do is figure out what my asymptote is. So my asymptote, remember, for any parent function of an exponential is y equals 0. So again, I look to see how did my y values change. Well, they were multiplied by 3, and that is a 0, even though it looks like a 1. And then we are subtracted by 1. Well, 3 times 0 is 0, and then 0 minus 1 is -1. So my horizontal asymptote is at y equals -1. And now I can graph my points. So -1 is at 0.10. 0 is at 2. And then 1 is all the way up at 7.15. And so it's this increasing exponential. And that is my final graph. So now I can answer my domain range and what everything is. So my domain is always going to be all real numbers. So -infinity to +infinity. For any exponential, it's always going to be all real numbers. And then my range, bottom to top, it's always going to be involving your asymptote. So with this one, it's just going to be from the asymptote to +infinity. So -1 to infinity. And then describe our transformations. The 3, remember when it's multiplying by the y values, it's causing that vertical compression. So the 3 caused not a compression, a vertical stretch. And then the -1 moved the graph down 1 unit. Because all of my points moved down, we subtracted the y values by 1. That's moving it down. Y is up and down. Okay, so those are graphing my exponential functions. Remember, you guys will get that parent function attached, but Just you need to know which one is which. Okay, so let's continue on with 3. I'm going to try and move this a little. Okay, there we go. So solve for x by getting a common base. That's telling you what to do. So it's telling us, okay, let's get a common base. So the common base between 5 and 125 is 5. So this one is already at 5, so I don't have to change anything there, but I can rewrite 1 over 125. Now, first, I know 125 is 5 to the third power. Then, to rewrite it as, instead of a fraction just by itself, I'm going to write it using negative exponents. So it's going to be 5 to the negative third power. So now that I have an exponential on each side, same base, I can set my exponents equal to each other. So 1 minus 2x equals negative 3. And now I can just solve for x. So subtract 1, and I get negative 2x equals negative 4. Divide both sides by negative 2, and I get x equals 2. So my final answer, x equals 2. Okay, let's keep going with our exponential. I'm going to go till 7 for this video, so we're going to go with that, just kind of that section. So 4 is the same thing. It's saying solve for x by getting a common base. So it's telling you what to do. So I look at 9 first, which is like my smallest number, and I think, okay, is there a way for me to rewrite all of these as a base of 9? And there isn't. 9 squared, which would be the simplest thing, is 81. So I have to go smaller. And so I know that 9 I can rewrite as 3 squared. 27 I can rewrite as 3 cubed. And then 243, like if you don't know, you can just do a guess and check. So I know it's 3 to the 5th power, but like if you didn't, you could go 3 to the 4th, 3 to the 5th, and just kind of guess and check, knowing what you know about these. So 243, we're just going to rewrite it as 3 to the 5th times, and then remember, okay, this is 3 squared, but when I write it not as a fraction, I'm going to rewrite it as 3 to the negative 2nd power, and then raised to the negative x equals 27 is 3 to the 3rd power raised to the negative 5x. And so now first thing I'm going to do is apply like my power property here. So power to a power, I'm going to multiply these together. And so I have 3 to the 5th times negative 2 times negative x is positive 2x. And then 3 times negative 5x is 3 to the negative 15x. And then the last thing I want to do is I want to get it so I have one exponential on both sides. I already have one exponential here. I need to get one exponential there. So I'm going to combine these. When we are multiplying and they have the same base, I can add the exponents. But 5 and 2x cannot combine. So we just would write it as 5 plus 2x equals 3 to the negative 15x. And so now I have one exponential on the left, one exponential on the right. So I'm going to set my exponents equal to each other. So 5 plus 2x equals negative 15x. So remember, when you're solving and you have x's on both sides, you want to move the x's to the same side. So subtract 2x, I get 5 equals negative 17x. And then divide both sides by negative 17, and I get x equals negative 5 over 17. Nothing more I can simplify, so I'm just going to write that as my answer. Okay, let's get into 5. So 5, same thing. It says solve for x by getting a common base. But I recognize that they already have a common base. So that part is done for me. All I have to do is combine and then set my exponents equal to each other. So when I'm multiplying and I have the same base, I'm going to add. Same with here, I'm going to add. Now with this side, I can combine a few things. Now x squared, I can't combine with anything else, but I can combine x and 2x to get me 3x, because 1x plus 2x is 3x, and then minus 9 can't combine with anything. And then those are not like terms, so I'm just going to rewrite it as 8x raised to, or 8 raised to the 4x plus 11. And so now I have one exponential on each side. I can set those exponents equal to each other and start to solve for x. So I have x squared plus 3x minus 9 equals 4x plus 11. And so this one is a little bit more challenging than the other ones that we've dealt with. The reason is we have an x squared. Whenever we have an x squared, we want to move everything to one side and solve by factoring. So I'm going to subtract the 4x from both sides. And honestly, I'm just going to do this in one step. I'm going to subtract the 11 from both sides too. And so that gets me x squared minus x minus 20 equals 0. So now I'm thinking, okay, what are my two numbers that multiply together to get me negative 20 and add to get me negative 1? So if you need to draw your x, and that would be negative 5 and positive 4. Because a is equal to 1, I can go straight into the shortcut and just go x minus 5, x plus 4 equals 0. And then because it's factored and set equal to 0, I can just set each factor equal to 0, and I get x equals 5, x equals negative 4. I don't have to check these. You only have to check these when your variable is part of a logarithmic argument. Other than that, I mean, yeah, of course you can check your work. You can plug it back in to make sure you get the right answer, but you don't have to check for extraneous solutions on this one. And so those are my two answers, and that's that. So let's get through 6 and 7, and then I'll start a new video. Okay, so 6 and 7, I will give you the formulas. The formulas will be there on your test, so you don't have to worry about memorizing them. You just have to know which one to use and when. So for 6, it says Ryan invests $2,000 into a savings account with a 2.43% interest rate compounded weekly. Determine how much money Ryan will have in the account after 15 years. So how do I know which one to use? This one is compounded within a time frame, compounded daily, monthly, weekly, quarterly. And so because this says compounded weekly, I know I'm going to be using this one. So I'm just going to identify everything. P, which is like my principal, my starting amount is $2,000. My rate is 2.43, but remember we've got to move it over 1, 2, so it's 0.0243. My N is the number of times it's compounded in 1 year. So it's compounded weekly. There are 52 weeks in 1 year. And then my time, how much will he have in 15 years? So time is 15. So I'm going to plug that into my formula. So it's going to be 2,000 times 1 plus 0.0243 divided by 52 raised to the 52 times 15. So into my calculator, I'm going to do that whole thing in my calculator, and I'm going to show you guys how I do that. So we see that. So it'd be 2,000 times, so I'm going to start my parentheses, 1 plus, and I'm going to put parentheses around 0.0243 divided by 52. Now I'm ending the parentheses. The first one is to end it on the division, and then the second one is to end it on the whole thing. Raise it to. Now I'm going to put parentheses around my whole exponent, 52 times 15. You technically don't need to in this calculator, but if you're using any other calculator, then you need to. So that's my answer. $2,879.34. And that's it. So let's move on to 7. Okay, so for 7, Heather invests $36,000 into a savings account with 10.3 interest rate compounded continuously. Determine how much money Heather will have in the account after 5 years. So when I see compounded continuously, that tells me I'm using the PERT formula, this one up here. So again, I just am identifying what everything is. P is my principal, my starting amount, so it's $36,000. R is my rate. So again, we just move it over 1, 2. So this is 0.103. And then the time, how much will Heather have in the account after 5 years? So T is 5. So when I plug that in, it's 36,000 times E raised to the 0.103 times 5. So when I do that in my calculator, I'm just, again, 36,000 times E. When I raise it, I'm going to put parentheses around 0.103 times 5. And then that should get me my final answer of $60,250.99. That's 6 rounds that 8 up to a 9. And that is my final answer. Okay, so I'm going to pause it here. I'll pick up the rest in another video and go from there.